on day one of the Bangalore event. So I would like to invite disaster response system moderators and co-moderators on the stage for discussing their topic. Suresh is here.
Yes, you can. Good morning, everyone. Welcome to the disaster management and mitigation session. And we would like to start with the progress we have done in the Delhi session, and followed by that Mumbai session, and yesterday in the Bangalore session. We have identified the key use case, which is the fire rescue operation, and how we can fasten it with the digital twin. And the proposed scenario is a high-rise building with a mid-floor fire and heavy winds. This is the scenario we have identified for the proof of concept. Please hold.
Good morning, everybody. One thing we wanted to add is in the fire rescue operation, there are two scenarios. One is a claustrophobic one, closed and closer types. The other one is a widespread one. So each has got its own challenges. In the closed, this thing, it'll be difficult to rescue people because they are in the high-rise building. To reach them is going to be difficult. That is, the rescuers would reach, but the action to be taken has its challenges. In the other case, what is happening is the rescuers will find it difficult to reach. Once they reach, they can do the needful. So these two. So to build up the model easily, we have taken the high-rise building. And in this case, we have tried to lock onto a building. Yeah, that other one you got?
Is the Dwarka building.
No, that one we had. The other one?
We are not.
No. Okay. We had been told that there is a building which had been identified. Since we didn't get the update on that, what we have done is we have taken a building in New Delhi in Dwarka. And we are considering a 10-story building with 60 flats. As we go ahead, we will start specifying the things. Please continue.
And this use case is definitely fit for Sangam because we are bringing in the competencies of all the contributors and getting a fast and intelligent response. We have identified 5 key layers, starting with a geometric layer, which is the base a GIS mapping, and informative layer where we add more information about the buildings and the scenarios, and an interactive layer, which is a real-time interactions from all the IoT sensors and the DOT occupancy of the flats. So these are the key interactive layers, and autonomous layers where we add all the A and ML and get analysis and insights of what could be the probable disaster response. And predictive layer is the what-if scenario, which does the situational awareness analysis and recommends the disaster forces to keep the response actions as per the recommended actions from the predictive layer. So predictive layer is the one which is interacting with the responders, including the fire, ambulance, and the police. We have put up a key workflow where we identify what we'll have when we have a distress alert from the user and how the workflow should progress from getting an alert by the distress response and how we should coordinate all the digital twin layers and consider the, conduct the distress response effectively. So we are still working on this workflow and more inputs is required from the contributors. And these are the key requirements in each layers. The geometric layer needs imagery, lidars, and maps, building informations. And informative layer where we need information on from the telco on common alerting protocol. And interactive layer where we have all the intelligent sensors and IoTs and surveillance feeds in real time. And autonomous twin, we are still identifying what are the requirements to it. And predictive twin, where we analyze the situation and give up the predictive responses analysis. Also, we have identified a few potential players in each layers, and we have detailed contributions from each players as well. Sure.
As far as the players or the contributors to each layer is concerned, we have started pitching in and we have said, this is the output required and this is what is being brought to the table by the contributors. This is not only to specify what is required, but also to throw open to the others in the environment if they find that they can contribute and take this ahead. So this is just a initiative to populate the digital twin requirements.
And this is the overall picture where each attributes will come integrated with the Sangam-Digital Twin. We have infrastructures, data and APIs and device providers and analytics and simulation and the virtual world, all integrated towards giving us the Sangam-Digital Twin. And we have segregated the layers into two, mainly a common layer, which is specific to all the digital twin verticals, health, disaster management, transport, and environment. Everyone will have a smart city or a city level digital twin. So this is a common layer, all the geometric information and the informative layer, all common to all the verticals. And interactive layer where we add all the real-time information and we then segregate to each verticals, health. All the three layers can be utilized by all the three verticals, all the four verticals. And the autonomous and the predictive outcomes is independent to each layer. For example, disaster management will need its own analysis and predictions, whereas the transport will need its own automation and prediction. So the bottom two layers, the top two layers we have segregated, dedicated to each vertical, but the bottom three layers are common to all the verticals. And any inputs is welcome on this. We are working out the detailed analysis of what are the data required, what are the hardware and software requirements, what will be the estimated cost for the POC, and technical challenges or regulatory challenges, who are the potential customers or users for this. So this is still in progress. We estimated a timeline of July for the POC, but we see an accelerated initiative with all the combined strengths from each potential players. There are other use cases like urban flood and cyclone, but we are not taking it for the POC. We will come to the constraints or feasibilities where the privacy is a major constraint. For disaster response, we assume the consent is already in place for all the privacy informations. And we discussed yesterday on who are the potential contributors for each layer. We identified a geometric layer for the POC of 10 floors with 60 flats in Delhi. We can modify it as per the building availability. And we identified who are the potential players, what can be the contributions from them. We had placeholders for a few players. They can add it post this session. Similarly, for the informative layer, where we add data link, documents, and search and query tools to the building informations. An interactive layer where we have a large amount of sensors and hardware which is in place giving the real-time information. We have added a placeholder for data which is not available as well. For example, CCTV with live feeds is not available from any players. So we have added a placeholder for it. Any players who will be willing to contribute can add their contributions here. Similarly, the autonomous layers is in progress, and the predictive layer we are working out in this session. Today we will close this. And that's all we have. Any comments or questions?
Yeah, any comments?
I have a question.
Here.
Just go to the previous slide where you have shown the workflow.
Yes.
Can you switch the slides, please?
This one, yes. So whenever there is a emergency call, we can also retitle disaster / emergency or emergency / disaster, because fire is considered, fire in the building is not a disaster, it is considered as an emergency.
Sure.
So if person makes a call, first thing is to determine the type of emergency and the level of emergency. And then you have to identify the geographical area from where this call is coming.
Yes.
So how currently it happens?
Currently, we are using an input from the distress people itself. But later it will be automated based on the sensors available.
No. If I am making a call that
Yes.
there is a fire in a
Yes.
particular building,
Yes.
And I am making call from mobile.
Yes.
So system knows from where I am calling.
Yes. So we have the
So there is
coordinates
a
from the user.
Coordinate, and even if you have a good database, even if you are making a call from landline, one can determine the location or the area. Then you can refine it. Next is that location is determined, area is determined, and type of the emergency and the level of emergency is determined.
Yes.
Who should be notified? So after fire department gets this alert, who else should be notified? So there is somewhere telcos will be involved.
Yes.
So means when we are coming up with the use case, telcos may be notified
Yes.
that they have to provide certain data
Yes.
at a certain stage.
Yes.
So how that notification will go, that should emerge in this picture.
Sure.
And fire department will be having its own twin about its inventory, firefighting equipment inventory, where they are located, their resources, skills. So if they want to deploy something, so they are aware
Yes.
about their system. And they are aware that where is the emergency. These two things are there. Then situational awareness of the road and other things will come into the picture, that how to reach to that place. What is the best way, what arrangements are to be made.
Yes.
So there may be some other people who may be involved to provide that path or to vacate the areas so that they can reach to the other areas. Once you reach there, then how you are providing a contextual instructions or how you are aware about the building digital twin. So where is the building digital twin?
Okay.
Because you know that these are the exit areas, this is the layout plan.
Yes.
And people can be asked to get assembled here, or even in the normal time, there are doors or entry points, but in emergency time, you can create some additional points,
Yes.
which may be converted. So what are the probable areas which can be leveraged to evacuate the people? So from where you will discover that? You will discover from the digital twin of the building.
Yes.
So there is a digital twin of the building, there is a digital twin of the inventory of the firefighting equipment, and there is a digital twin of the roads and the situational awareness of the roads. So these three things are there.
Yes.
Then there is a telco who is helping you to provide more information and get connected with the right people.
Yes.
And who are those people? There may be volunteers who want to help. There may be the people who are trapped, and you want to coordinate with them. And you have to provide a contextual instructions on a digital twin.
Yes.
So how that is provided, how that is superimposed. And then you run exercise again. That this was the situation when we started the operation. We made some arrangement. We asked people to follow some instructions. Now what is the situation?
Sure.
So even after some time, after 15 minutes, 20 minutes, then you have to again reassess the situation. That what we are planning, yes, people are following that and we have achieved something or not. So that will become part of this.
Sure. I would like to add a few comments there.
Yeah.
Please finish.
Yeah. So this is a process.
Sure.
So in the beginning, you assess the situation, then you planned something, then you executed partly, then you executed completely.
Okay.
And this will be the flow. and there will be a multiple digital twins
Yes.
which will be interacting,
Yes.
and who will be orchestrating the process of this interaction between digital twin. That should emerge.
Sure.
So there is a orchestration layer, a core fabric connecting to the multiple digital twin. How that you can present that.
Sure.
And you can stage by stage from where you have started and when you have executed or accomplished the task, that should emerge.
Sure.
I think that will give a better picture.
Sure, sure. The core fabric is worked in the data, AI, and governance horizontal. We'll incorporate those and integrate with the disaster management.
Details may be there.
Okay.
Details may be there,
Yes.
but it should emerge here.
Sure,
That
sure.
you require it.
Sure, sure,
Those details will be there.
sure, sure. You want to add up?
Sir, based on the query which you have raised, sir, what both ends are clear to us, that there is a fire taken place and people have to be rescued and fire to be stopped. So both ends are very clear. So the way it will be triggered is the moment the fire occurs, we know for this particular disaster, the active people are supposed to be the fire services. But they may not be the first people who will reach. The first people who will be in that area is that, let us say this building is part of a society, the security personnel of that people will be there. So they will be there. Then the second people who are to be incorporated is the police people, because they'll have to cordon off that area, maybe direct the traffic to that place. Third people will be the health. So the moment the fire is there, the digital twin, the way we have planned is, it will trigger.
It is not emerging in the presentation.
No, I understood, sir. What I am saying is,
what is in your mind, that should be become part of the our block diagrams and a schematic diagram.
correct. So what I am bringing to is that this is what we are coming, so that if there is any more input when we come with the final picture, it can be brought out now, it seems.
So if there is a digital twin of a health ecosystem,
Correct.
there is a digital twin of the fire ecosystem, then there is a digital twin of a building, and then telco. So if they are orchestrating some process, so there is an orchestration layer that should be presented, because one can understand. Yes.
So if
these
I
are the
understand,
actors.
if I understand rightly, now the building is there, and the moment the fire takes place, the disaster management digital twin pops up. But there is already existing health ka digital twin. There is already existing police ka digital twin. Once the thing is on the thing, then these two start connecting with each other,
Yes.
and then the active.
Yes.
Okay, that workflow and how.
And when somebody who is trapped inside the building is making a call, but digital twin of the building is also sending some alert.
Correct.
Because they have a fire sensors like that. So you are equipped with more information, and all the information is mapped on a composite twin. So these are the twins, and then for the action you are having a composite twin, and where everything relevant, every relevant thing is mapped on that. Probably that may be the way. Others can suggest, but that we should be able to see that there is a composite twin, there are multiple twins, there is an orchestration layer, and how it is applied in the case of a fire.
Then we'll bring that, and the first thing what we will do is we'll run an idyllic situation without that whatever has been planned has gone smoothly. Then we will bring in the first contingency, that the fire service has not reached the place. What is the next action going to be?
Right.
Then the second contingency will the police people have not reached. Who takes on there? Third would be the ambulance is not reached. So these contingencies we'll build in, and then we will say how to incorporate.
Yeah.
And next thing is, at any place, if we have too many, kings directing the battle, it will be difficult. So at each stage, if the security is there, he takes the charge. But the moment police comes, he hands over the charge to the police. And the moment the fire service comes, police hand over the charge to the fire service. So we should have only one person directing the thing. If many people are directing,
वो तो digital twin multiple लोग भी काम कैसे कर सकते हैं? Digital twin can give you more levers.
नहीं है sir.
More levers.
हाँ.
एक है human organization कैसे काम करते हैं? एक human organization digital twin enabled environment में कैसे काम करते हैं? So that can be done. My point is that you are considering that high-rise building as a use case.
Correct.
But I think what you are preparing, it is not limited to high-rise.
It is not. It is not limited.
It is not limited.
No, it
So
is not limited.
You can broaden that area. Demonstration may be for a particular area,
Huh.
but it is not limited to that.
Okay.
So you can have a wider area, slum, or a clusters.
Okay, you mean to say we create for digital twin.
Means
after
what
that,
what we are discussing is not limited to a high-rise building.
it is not. It is not.
It is much broader.
Correct.
So in the beginning, it should not appear that it is only for the high-rise.
Okay. Okay.
On demonstration piece may be for a particular building or a specific area. And many of this stuff is also applicable for cyclone or a flood area.
Huh.
So common part of this presentation or this effort is applicable for variety of disaster use cases.
Understood. That we build up we say ki these are the two being considered.
Yeah.
We build up a skeleton.
Yeah.
And then the skeleton, the moment it goes to a different scenario, how it builds its muscles and bones.
Right.
That, yes, we will go on to that.
Don't have a vertical for digital twin for buildings. So I think then in that case we have to add a vertical for digital twin for buildings as well, because our current cases are healthcare, disaster management. So do you think adding a vertical for buildings also would be a suggestion, so that a digital any building related vertical we can connect it with a digital twin for building?
So you can consider digital twin of the building as a part of your use case, because it should be equipped with the fire extinguishers. It should be aware that mock drill was conducted timely, and all the fire equipments were tested. So there is a digital twin which is updated with the placement of the fire extinguishers. It is equipped that when these were tested and these have not expired, and mock drill was conducted. So there is a status of the building. It is not only a layout plan.
Sir,
It is also equipped with the real-time information.
Okay, sir, my suggestion was that then in that case, there can be many use cases for buildings. Disaster is one, healthcare can be another one. So can we also have a vertical for building digital twin as well?
Maybe can I add here? So for some high-rise buildings, we can mandate that they have a digital twin. So BMI, the building infrastructure thing is something that is also possible. And to have with all the details about the water pipe connections, the fire extinction and all these things. But then when it comes to the emergency or disaster handling, we should also take care that not all buildings would have. Maybe high-rise buildings, apartments, we can enforce as per law that they need to have this part of it for all these emergency responses.
Disaster
But
management,
like for example, slums and all these things. So
It should be a
we should
cluster.
also look at how do we dynamically build the environment during this. So there are newer technologies possible, like with CCTV cameras or drone-based survey of that situation. So telcos could help here, and drone operators could help here to, when there is a call, you go and survey and give these insights into it, so that you could have the handy both all the people, police or healthcare or the fire department. They have an awareness about the exact situation where the event has and what the problems and things.
Understand. So my question was the building digital twin should be a
Yes,
vertical or should
you
be
can
a part
suggest.
of-
You can
Yeah.
suggest. The final comment. Just
Yes.
Yeah, you are right. You are right. Currently, this picture is not very clear. If there will be a multiple digital twins, then it will become more clearer. Yeah.
So what I can add here is, right now we are trying to build up for fire specifically. As the thing comes up, we will know that there is a requirement for a digital twin. It can peel off onto that. At the same time, there would be a fire for healthcare digital twin popping up. Then we need not go from the firefighting to build up healthcare.
Those
From
will
there,
be working
from there it will flow in.
So they can work independently.
Correct.
They have to hook on a core fabric.
Yes, sir.
Okay.
So right now what we will assume is there are digital twins, and then go ahead.
Yeah. Yes. And last point. Mock drills can operate in this environment.
Okay.
So they can be done in a virtual world. so it can be more frequent and more precise. So what you are developing, it is not only for operating purpose, it is also for training purposes.
Yes.
Correct.
That you can mention.
Sure. We have identified 2 use cases of training and preparedness with this digital twin, and 2 aspects of response and recovery with this digital twin. Sure. Thank you.
Next, I would like to invite Mr. Rajat Mathur for the transportation use case, along with the other co-moderators, Professor Vadi Raja.
Good morning, everyone. I'm Rajat. I'm partner with BCG and lead and moderating the transport and mobility use case. So we had a very engaging discussion in Bangalore, and I think one of the very shaping discussions that I would say across the 3 cities that we have been so far. So what I'm going to tell in next few minutes, let me just structure that conversation first. So first of all, a very quick brief as what has happened there. I'll just talk about that. And next would be about what are we planning to achieve today, so that we can have a comprehensive, well-knit story by the end of today. So let me start with the first point on how has been our discussion. So we started with giving almost took 1 hour to bring everybody on the same page. What we had done in last 2 networking events is that we have narrowed down our use case, as well as within the use case, all the details about what is a typical use case, what kind of a data are we talking about, what kind of a architecture we are talking about, what kind of enablers we are talking about. In fact, our use case that we came to Bangalore was that we have to decongest the city of Delhi while developing a 6 months POC and then handed it over to, let's say, the Commissioner of Police to implement that. Within that, as I said, we had identified the key data sources, which is predominantly coming from telco data, Book My Show for any external event, weather data, and host of other data. We had closed on the architecture, and we have identified some of the strong enabler. We even went down to, in Delhi and Bombay, we even went down to this extent that what all things would be in the purview of commissioners, so that he can implement, or he or she can implement that very quickly, and we can see the results. So we restricted ourselves only to, let's say, parking, let's say workforce deployment, where all the traffic constables needs to be deployed, or trying out or experimenting out in the 1 or 2 way traffic there. We hold our thoughts for not changing, let's say, the traffic lights or the positioning of the traffic lights, the timing of the traffic lights, because that's altogether a different work stream, or I would say a significantly different purview from what traffic commissioner can implement that and see the results. All that actually was prepared up, and we brought everyone on the same page. While bringing on the same page, we sought for feedback as well, and I think there were very good feedback, especially on the data sources. There's a very strong or a good comment which came in that, what's in it for the commissioner? Okay, you will improve, let's say, the decongestion, etc., but can you think of monetizing this? So that came out as another option, that can we give commissioner an opportunity to monetize the work that we are doing for him, so that there is an amount of money which is made for him. And last but not the least is about, again, a push on how do we end up implementing it and measuring it. So Delhi and Bombay, we had thought through a baselining approach, that how would we baseline the current scenario of Delhi in terms of the speed of the traffic, the flow of the traffic, and so on and so forth. And again, we concluded pretty much on the same way that, of course, you need a couple of more parameters such as AQI or carbon emissions as well, to ensure that pre and post pilot, we are able to demonstrate a good impact on these 3-4 KPIs. So these are the 3-4 things that we concluded on bringing everybody on the same page as we all the hard work of that particular use case that we had shaped up. So what we did next was that we said that, okay, we have a checkbox of this use case. Can we now push ourselves and think of a second use case? Now, the second use case came out, which is, again, dovetailing to what we had thought about it, is that optimizing the multimodal environment or multimodal transport network for city like Delhi or Mumbai. And again, very good inputs came from what already a work done in Bangalore by some of the team members there. So we said that, okay, let's have this, because we cannot, what we want to do is that we want to run a POC for 6 months and get it implemented in, let's say, 6 to 12 months, so that we can see the results. We don't want to do a POC of, let's say, an 18 months and then again an implementation of around 36 months. We'll lose out the fizzle. That's what our focus was, and keeping that focus in mind, what we did was, we shaped this use case also in a similar way. So we said that for optimization of this multimodal, let's pick up, let's say, the metro timings, the new metro routes, and of course the existing bus network that we have. If we can optimize the existing bus network, if we can give recommendations that the timings of the metro, or let's say the stop of the metro times and so on and so forth, it can also shape up in a good use case where the decongestion of a city can happen there. So that was where we concluded that this was the second use case that we will pick it up. Earlier also, and this time also, we had already identified our potential customers, which is the Commissioner of Traffic Police. This time also, I think we did discuss that, what can be the potential opportunity for monetization, and I think one suggestion came in that potential Namma-Bengaluru, I mean, there is an app there. If we can give them insights that where is the traffic density going to be at this particular time, maybe those guys can subscribe to these insights from, let's say, the Commissioner of Police or the police department, traffic police department, and they can monetize this offering that we are end up creating for them. The second option was, which was discussing for potential monetization of, is it digital or intelligent challan, is still up for debate. So that's what the summary of what has been done there. Now, what we plan to achieve, just like our previous use case, we had everything detailed out of data, architecture, enablers, the value or potential value that we are talking about, the milestones, the entire roadmap. We like to do the same for this particular use case of multimodal transportation there. We anyway have the data sources identified. We'll push ourselves today for getting the architecture checked out. We push ourselves to get the enabler and write a very detailed roadmap. Personally, I don't think we'll be able to quantify a value as of now, that what is the dollar-rupee value that a city can actually save, or let's say the potential impact on the carbon emission through a pilot on that. But at least directionally we'll be getting there. So that's what our progress has been. In the evening, we'll come up with a presentation and show what all things we have discussed and achieved there. So you want to add anything? Or? Yeah. Let me take a final pause. Any questions, thoughts? Sure.
So how are you going to quantify that, and how are you going to measure that?
Maybe reaching out to you, that's the first step for us. So see, I think this is where we mentioned about a collaboration with the environment model. Right now, we have a way, like we have thought through some, so what we are thinking, let's say about in Delhi, let's say if we can contour ourselves to, let's say, Connaught Place or let's say Janakpuri, 3 areas. But before our pilot starts, what is the typical CO2 emission that we are, or AQI that we are observing? What is a typical AQI which we have seen in last 2-3 years during this window? And once we implement that pilot, what is the AQI that we observe, and what is the AQI that you have in the past few years, so that we can have a pre and post comparison.
Yeah, baseline analysis and
Correct.
post.
Exactly. So baselining, we have achieved that. We'll achieve the baseline and then do a post-facto analysis.
Okay, thank you.
Just continuing from this AQI, what I could immediately suggest, just it's out of the box thinking. See, we can deploy sensors. In the sense, there is already along the road, the street lights are there. So there we put up, and these days sensors have become smart with MEMS, TEMS and all coming. So these sensors can, transmit even wired. You need not restrict yourself to wireless communication. You can. and then gather the data. So the digital twin can suggest that so and so places we should have sensors.
Got it.
And along with that, like yesterday during one of the horizontal, the rain is an issue. So that also a sensor to measure the rainfall, and so that it can predict as to what is the water logging going to be. So these two sensors may come out as a digital twin. Then secondly, what I was thinking is, see, we are speaking about the congestion. So there are various factors which is coming for the congestion. If the digital twin can identify, classify, and get something known as an impact factor, that there is a particular accident, so there will be a congestion leading to so and so, then people can, or the authorities can have a model in which to respond to a known thing. Because when we are doing a project, unknown is difficult. But if that unknown at some point can become known, then known unknown we can still address. So that was one point. The second is, when you are considering multimodal, it would be prudent to consider drones and VTOLs, because the way we are advancing, and we have been part to the air mobility seminar in which VTOLs are going to come. So ab initio, if you can factor in that, you will be better prepared. The digital twin need not undergo a fresh review when the VTOL actually comes into place. Third is the cameras which are being placed. Just like sensors, the digital twin can say that the positioning of the camera will cover so and so area. And sometimes what happens is, in the control room, multiple screens are there. It becomes little difficult when there is a change of guard, because you see there is duty allotments and there is an overlap.
True.
But if I am suddenly walking into the thing which I have seen when we were in the control room for a flood relief, all of a sudden to lock yourself to these two screens are related to each other, it becomes a difficult proposition. So the range as well as the sequencing of the cameras. Many times you will find that at a road junction, one camera is on the right top of the grid, the other is somewhere in the center, so you are just trying to place. So the sequencing of the screen should be there. And another point is regarding the trackers. See, we are now assuming that people are with mobiles, so because of the mobile response, that is how the crowding up in a particular place occurs. But in a place like Delhi, you will find tractors coming, trolleys coming, which by no means they will have tractor. So can you have a few bikes which can take through, we can wriggle through, and then you will get to know where this congestion is taking place. That could be a part of the response system, because when the bikes are moving, they will be already fitted with tractor, and you will be able to come to know. Last, you said, yes, rightly, the revenue at this point is difficult. But what I could suggest is, you could find out the the possible revenue reduction contributors by first identifying who are the revenue increase contributors. Who is going to give me a more increase? So because of this person, I have to spend so and so, or because of this construction, I have to spend so and so. So who is the counter for that? So with that, we can get a ballpark figure and throw it to the environment. Obviously, you will be raising hackles of many places. So let those people respond, and from their response, we'll be able to stitch in the...
Perfect. No, I think all good inputs. In fact, when she talked about the AQI part, frankly, yes, with sensors, we can at least get to the environment. But even with the right quality of cameras, the other portions of the KPIs that I'm talking about that are still being debated. Can we accurately get the flow? Can we really get a good hang of the average speeds from the camera, etc.? So that's also being talked about. So you're right. I mean, I think if sensors can help do a better measurement of our KPIs, then why not, especially in the pre and post scenario that we want to demonstrate. And there has to be consistency so that there's no question on the final output. On the revenue parts, I think spot on. that's what I think, it's a good push that we got yesterday. Let's keep socializing it in this forum and in Hyderabad. The cost factors are definitely there. For instance, the cost for the workforce deployment, plus the potential increase if you are able to do a good job in the modal share. For example, more people taking a bus or a metro. That's again an uptake on the government. But yes, I think what's in it for me kind of a question needs to be answered in a more smarter way, rather than just roaming around the bushes on that front. Right. Thank you so much for
just one
yeah,
question.
Sure, sir, please.
So because it's multimodal and you mentioned that the data sources are already identified. So my question is, because it's a multimodal, which are those identified data sources and the enablers? Because, yeah.
Sure. I don't have, let me just start with the first one is definitely the OD matrix. The next one that we identified was, let's say, some special events. Let's say Book My Show, which says that, okay, there is a IPL match, there is weather data, there is data coming from public transport, which is, let's say, the check-in, check-out from, let's say, the metro, the schedule data, which is publicly available, weather data, weather API, which is coming out on that front. Of course, then the 3D GIS maps. The 3D GIS map, you have LiDAR, you have video data, video analytics data. Then you have potentially, maps we covered. Potentially, if at all Ola and Uber comes in, they can also help us do the triangulation or the corroboration of our OD matrix. The connected cars, if and all they come up, the urban planning maps. So these are some of the data sources that we identified. I may have missed a couple of them, but I have the laundry list with us.
Yeah, one more thing is, you see, a place like Delhi, if there was some event, the district administration is always requisitioned for. So that could be a principal source, and the digital twin can say the moment they get the input, they should trigger the intimation by default.
Yeah.
So that everyone comes to know.
Yes, these are the enablers for a successful digital twin, that yes, we have given a system, now people should be able to use it in such scenarios that you just talked about. Right, folks, any other thoughts, question? So.
Just one suggestion,
sure, sir.
That probably transport use case has reached to certain maturity level. Now it's time to have more interaction with the horizontal layers, that how we can elevate it from the perspective of the virtual world and from the data privacy perspective.
Yeah.
So we can have an interaction with them.
Perfect. I think we'd invite both the data, the privacy one, and the virtual reality ones to join us. I think it would be really good to have your inputs as well to amp it up and get to a closure on this. Perfect.
Sir, what you would be meaning is the transport has their transport, like disaster management, they would be requiring transports, how that factors in. Healthcare would be requiring transport, how that factors in. That's what you would like to be shared to them, if I'm not wrong.
Yes.
Yeah. Frankly, sir, sorry, I don't think, at least I have been a moderator on all 3 cities. I don't think I have interacted with my fellow moderators on a potential collaboration. That I would definitely, transport definitely needs some inputs from, let's say, environment. We definitely have to help or collaborate disaster or emergency. Emergency hogi to kaise, matlab, if there's a mass casualty happened somewhere in CP, then how would things be directed there? I don't think we have collaborated, and nor we have given thought to it ki ye kaise hoga. So I think maybe this is a good opportunity that after our sessions, let's have a 15, 20 or a half an hour, 1 hour catch up.
On this point on the horizontals getting interacted, yesterday's one of your points was we are talking about aggregated data itself. In the context of aggregation, although privacy is important, but I'm just still, after the discussion that you kind of put it right, we are talking about aggregated data. What kind of privacy in the context of aggregation are we talking about? Because that was something I was trying to digest yesterday night after your conversation in the horizontal stuff.
No, I think we will discuss during the privacy session.
Sure.
And that is
Sure.
relevant for that privacy
Sure,
session.
sure, thank you.
Perfect. Thank you, everyone.
Thank you. Next, I would like to invite healthcare use case moderators and co-moderators for their presentation.
Yeah, hi, good morning. I think healthcare digital twin has been something which has been the most volatile since the Delhi event, and we have been like trying to find a good use case wherein we can finalize what could be the POC stuff that we can take after the Hyderabad session, right? So the recent incident that happened day before yesterday gave some thoughts and how we can see we can put up a use case for healthcare digital twin over here. In this particular case, the event that has happened in the past. However, it is just 2 days. But what I'm looking at is the events that are going to come in future. So here in this case, take an example of, we can present. Take an example of Kumbh Mela, right? So it's scheduled in the year 2025 at Prayagraj. Now this is a major event, around 40 crore people coming over there, and we cannot even afford to think of eventualities that happened day before yesterday. So can we have a digital twin which can simulate and probably help us in terms of managing and organizing such an event and not having any kind of casualties, and the event goes very smoothly. Now this particular event has been happening for ages, right? And the planning and effort that goes into these kind of events is tremendous. Year on year, like government, the authorities, the local bodies, they have enough data at hand to organize such an event. So the idea of this particular use case is not to simulate only for Kumbh Mela, but it is to extrapolate and try to use this particular platform for other scenarios wherein you have events and tourisms where the crowd comes in. So it's more of a crowd management digital twin going along with a healthcare digital twin, and that's the idea, right? So when we talk about healthcare, what are we looking at? We are looking at during these large events, what can happen. You have communicable diseases. Since people are traveling from various different regions across the country, across the globe, I would say, in terms of Kumbh Mela, people come across the globe. They are not very familiar with what is the climatic conditions and environment conditions of the region. And maybe it's too cold or maybe it's too hot for them. So we need to prepare. So I just took heat stroke as an example, but there can be many such examples based on the climatic conditions at that point in time when the Mela is being. There are common problems, respiratory problems, skin infections, accidents and injuries. I've highlighted that because of the Hathras incident, right? Stampede is a major possibility. Now, how we can avoid this possibility is something which we have to look at. And of course, comorbid patients, a lot of old people travel to Kumbh Melas, and we need to take care of them as well, right? Who are the stakeholders? When I talk about a digital twin, I'm talking about a command center. Of course, when you talk about Kumbh Melas, you can actually visualize the command centers put in place, and they really have a very good infrastructure supporting them. And this is just to try to see, let's say, Kumbh Mela being a planned event, we know that the infrastructure, the planning and everything goes into that. But the Hathras incident, let's take that as an example. The authorities probably did not think that the crowd will be so big. So they did not plan for that. And that's why all the eventualities. So if we have a digital twin for a scenario like Kumbh Mela, and we can take it to Hathras, and before we sanction or approve any kind of, permissions for that kind of events, right? You can simulate and say whether it is possible, not possible, or if you are sanctioning that particular event, what are the, precautions that you can take, right? So that's where, so you have all these stakeholders. One more thing which probably taking a cue from what Rajat was talking about, we can integrate with various other digital twins. So you have the transport digital twin, which is there. You have the environment digital twin, which is the disaster digital twin, which is there. So whenever an eventuality happens, at that point in time, we can integrate with these digital twins and seek their help, right? The focus is more on the healthcare digital twin, right? In this particular case, we are talking about integrating with public health authorities, technology providers, research institutions, ambulance services. Again, it's part of the transport stuff. Healthcare providers, we are talking about both local and remote. because in case of any eventuality, if you need more doctors, more healthcare service providers, we need to rope them in and pull them from different regions. So how do we do that? If at all we have to connect locally, how we make use of cloud service providers, and how we can, provide those services is something which we need to look at. And most importantly, the discrete health digital twins, right? So yesterday when we were having this session, most of us were talking of discrete digital twins, right? And they will go in silos, they'll work in silos, when somewhere they have to integrate with the platform, because that's the idea. So whenever there is a need for integrating or going into the discrete digital twin, we can go over there. And that's where, and I think Aditya will be getting more into the depth of what is a discrete digital twin and how it goes about.
So maybe we can finish this and later show the discrete.
Yeah. So the data sources, we have identified different data sources, both from a health data point of view and from a crowd management point of view. So this is the information that we have. We have got public health database, right, coming from EHR, healthcare providers. Wearable devices is something which is a wish list. I'm not sure how economically or financially feasible it would be, but still, if we can have devices which is economical and can be used, this is something which we can talk about, right? We have disease surveillance systems already there, because Kumbh Mela, like events, they already have all these plannings in place, and they have executed that every time. We have seen successful Kumbh Melas in the past, so it's already there. Environmental health data, telemedicine platforms, wherein all we can get all this information. Of course, from a crowd management perspective, we are talking about geospatial data, transportation networks. Now, here in this case, transportation networks becomes important, because the bookings of people traveling to, let's say, Prayagraj would start well in advance. If they are traveling by train, at least 4 months in advance, or if they are traveling by any other means of transport, we will have those data, right? And this is a 50-day event, right? So the people will keep flowing. And if, let's say, if there are any eventualities and we need to restrict the movement of people to that region, then the transport authorities will come into play, and the transport networks will come into play. We have mobile network data. The telco will provide all the information required. Surveillance cameras already in place, well executed during these events, but more intelligence into these surveillance cameras and crowd management using the surveillance cameras can always help. Right? We have event management systems. So we talked about how event management platforms can provide data on how people are coming in, what is the kind of people movement that is going to happen. We'll get that. The ticketing and stuff happens on their platform. And of course, we have social media platforms for communicating to and fro of whatever is happening at the event. The key benefits that we are looking at simulation, prediction, and real-time monitoring. We'll see the benefits over here. Here in this case, as I said, Kumbh Mela is something which is proven, right? People have been organizing, people have been attending and going from the Kumbh Mela. But the data that we have, if we can put it on the platform, simulate, and then use it for some other events, that will help. So large events, whenever they are being organized, we can have simulation done for that. Based on the simulations, we can come up with predictions, what can happen, and how the authorities have to be prepared for that. If they have to have additional forces to be put in place, they should be able to plan for that. And for that, they need data. So that's where the prediction comes in. And of course, as the event is happening, real-time monitoring is something which we are looking for. And we have to do real-time monitoring. We have talked about that in the slides above. So going to the next. So, yeah, the benefits of Sangam-Digital Twin, right? Here in this case, I'll not dwell on the crowd management digital twin a lot, because the focus is on the healthcare. Here we are talking about real-time medical response, heat stroke prevention by proactively telling people like how to take care of themselves, and if at all the temperatures soar high or if temperatures go down, what are the preventive measures that the local authorities have to take care. So all those information. Prevention and spread of communicable diseases, because that's a big case in terms of event of this size, which goes for 50 days. It's not a 1 or 2 day event. People are staying there, people come and go, there's a lot of movement. So it's possible that they bring in diseases and they take diseases from that particular place. So that has to be managed. traffic movement restrictions based on the health events. So let's say if there are health events occurring, if there is any eventuality happening over there, in that particular case, the traffic movement restrictions and stuff needs to be planned. I was interacting with Pranay, and he is from Prayagraj, and he knows firsthand, like there are old people coming, there are senior citizens coming to the event, and at that point in time, there is a lot of mental stress and anxiety in them because most of them travel alone, and at that point in time, some support system for them need to be planned, and that is something which you're looking at. Communication and coordination goes without saying. Augmenting health infrastructure, as I said, based on the crowd that's coming in and staying at that particular location, the infrastructure has to be capable of taking care of all those situations. So the augmentation of healthcare infrastructure is important. And scenario-based preparation for medical situations. So while we are like having real-time monitoring and stuff happening, but if we predict or if we simulate certain scenarios and know that this can happen based on certain conditions, we should be able to create that simulation and prevent those things from happening. Of course, public-private partnership between supply chain, because in this particular case, when we're talking about health, there is a lot of infrastructure and pharmacy go hand in hand. So coordination with the supply chain is very important. And finally, there will be a lot of, I would say, medical practitioners who will be part of this Mela as a participant. So we can have those data also. Like whenever there is an event or there is an activity happening, right, we will have people who are qualified, who are probably capable of handling situations in case of an eventuality. So they can volunteer and actually be a part of the response team whenever necessary. Yeah, so that's it from my side. I would hand it over to Aditya to take it to the discrete digital twin.
Thank you. So there was a lot of discussion yesterday when we were talking about digital health digital twins very specifically. So I have a few use cases unrelated to disaster management, but some of the work that was, some of the preliminary work that we have done in our lab regarding the health digital twins. So in today's conversation in the healthcare vertical, we would like to discuss on specific health digital twin use cases that apply very well in the Kumbh Mela scenario or any crowd management scenario. So there are a few examples of digital twins, use cases of digital twins that we are trying to build. One is a gut twin. This is inspired by the Ayurvedic principle of taking care of your gut health properly. If you are able to take care of your gut health, then all the diseases that probably 90% of the diseases that come to you come through the gut health. So what we have done is we have shortlisted among the millions of bacteria. There are about 50 to 60 phyla that are available in our gut, and we have shortlisted about 5 different phyla, Bacteroidetes, and those that you see here. And based on this, we can actually go ahead and create a nice visualization. One thing that we do to kickstart the digital twin is to get a stool test done of a patient, and we can visualize that in a virtual reality by displaying the gut health. We can show that as particle systems. We can populate it with color-coded things, and this will give a pretty decent idea of what is the composition of bacteria in the gut system. And if the composition changes in a certain way, then the health of the person changes. So the doctors who are available, the doctors who have visibility of this gut health can now administer medicine. Instead of asking the patient to come back after 3 days, let us see how the progression of the disease is, they can right there simulate the progression of the disease for the next 3 days or 5 days, and change the dosage or change the medication itself, and administer proper medicine in the first place itself. So that is the idea of the gut digital twin. Again, we have another published work that we have done in the heart digital twin. So what we have done is, ideally 12 lead ECG is taken, so for getting the ECG of the heart. So, but all of us wear smartwatches and we get ECG from the smartwatches. So we thought we should be able to use this one lead ECG data to predict something. So if there is some difference in the signal, the voltage signal in the thoracic region, then there are about 16 to 17 cardio diseases that could be detected because of just ECG. So one thing that we did was we collected these ECG signals, we applied some deep learning models on top of these ECGs to detect something called as an arterial fibrillation using deep neural network. And we calculate the EF burden, the arterial fibrillation burden on the heart. So for somebody, we keep hearing this quite often. So there was no symptoms, there was nothing, all of a sudden there was a heart attack and somebody expired. So what we have learned is there will be symptoms, there will be some small signs, but we misread those symptoms, even doctors misread those symptoms. So we should be able to use these digital twins for tracking the health of a heart, and we can alert the patient saying that there is some burden on your heart, why don't you go and look at consult a doctor. So otherwise he can go along with his life. So another example of a patient, virtual patient digital twin that we have created specifically for medical training. There was discussion in the healthcare vertical about how we could educate people, come up with innovative techniques for skill development in the healthcare sector itself. So this is a short video that I would like to show of a health digital twin of a virtual patient who will be walking into a clinical setup. And this is powered by Hugging Face Llama model. We can converse with this virtual patient, while the student doctor will be wearing the headset and kind of diagonizing. So that is the use case that we have built. I'll just show you this video, you can have a look at it. So this is the virtual patient, it is powered by Llama model, and we are also looking at how we could model showing
Hi,
symptoms.
what brings you here today?
I have come to the hospital.
A minute, I think the voice is...
Hi, what brings you here today?
I have come to the hospital as I have been experiencing symptoms of food poisoning, and I am seeking a diagnosis for my condition.
What are your symptoms?
I'm not getting the volume.
I have been having severe abdominal pain, nausea, vomiting, and diarrhea.
How long have you experienced these symptoms for?
For the past 2 days, I have been experiencing these symptoms.
It's because it is taking the HDM, I think. Speakers kodla? Yeah.
Hi, what brings you here today?
I have come to the hospital as I have been experiencing symptoms of food poisoning, and I am seeking a diagnosis for my condition.
What are your symptoms?
I have been having severe abdominal pain, nausea, vomiting, and diarrhea.
How long have you experienced these symptoms for?
For the past 2 days, I have been experiencing these symptoms.
So we are using a Hugging Face Llama model. There are challenges. It has to be fine-tuned for the specific purpose. The patients, so we are able to also detect pulse, the vibrators on the controllers that we have that will actually give us the haptic feedback also. So we have used generative AI GAN models, pro-GANs for generating X-rays of cardiomegaly, emphysema, tuberculosis, normal X-rays. These are X-rays that we are generating of a patient with a specific condition. And we also can generate some blood reports if the doctor wants to have a look at the blood reports and diagnose that particular patient. We are working on longitudinal diagnosis. We are working on making the interactions more ambiguous, because the patients will be as ambiguous. If the doctor asks, when did you develop cough? They will not say exactly 3 days before or a few hours late before. They will say sometime in this week, earlier this week, I developed cough, something like that. So we want to also build, kind of bring in those ambiguous conversations from the patient side. So from this is not an executable digital twin, but a mock-up of a human body, which we have created using 3-dimensional modeling and for anatomy class. Typically, when Asit was talking about this morning, if you are able to play around with the human body in front of you at any point in time and press a reset button, and all the parts of the body will go and sit in its rightful place. So can we do something like that was the idea. So we have created this augmented reality setup where students should be able to go and play around with different parts of the body, dissect the parts of the, also label it, take a test right there, and model some of these things. So this is another use case that we have developed for biomechanical digital twins. So especially in the rural India, people are not even aware that they have to get a physiotherapy rehabilitation. And because of that, their post-operative recovery, not even, sometimes even for stroke recovery, they don't go through physiotherapy. And this is one of the things that we did. We can capture the real-time biomechanical movement of a human body with wearable sensors on top of it, IMU sensors on top of it, and we can reconstruct those motions on a virtual avatar. So somebody who is a physiotherapist who is remotely located can now get this particular insight as to how his patient is progressing in rehabilitation. So what I have seen in South Korea is hospitals give out suits rent out suits to their patients, and they will ask them to go home and continue the physiotherapy exercises, while the doctors will get this information in real time, and they can look at the progression of their patients. What is the advantage? The advantage is if there is some issue, then there is immediate intervention, so that you don't wait until the problem becomes very huge. And also there are other use cases for this. For example, sports training. I know of Mumbai Indians and RCB. There is a company in Bangalore which is providing these solutions for sports training, gait analysis, authentication, and such things. So this is another interesting training thing. This is a work in progress. So what we have done is we are working very closely with the nursing school in PESU, and we have created this immersive experience where a nurse is going to learn how to do IV insertion. So the entire workflow of how to do an IV insertion, starting from sanitizing the hand, wearing the gloves, scrubbing the alcohol, spirit on the body, and inserting the IV. So right now, what they do is they train the senior nurse, train the junior nurse on the patient bedside. Quite often, so because the patients would have enrolled for a teaching hospital, and they get some discount in the bill, they would have signed that you can experiment on my body. So can we do something in the, this is a mock-up, it's not an executable twin, it's more of a, training and education kind of environment, where we could actually look at the patient's profile. We can create a pretty accurate, decent digital twin of a patient whose conditions are already diagnosed and all, and we can place them on the bedside here, and the nurse can practice how to give health care to that particular patient. So also some pop-ups come there so that the new nurse, the trainee nurse can actually understand what are the things that they have to do. If they are doing it properly, then they get some points. They are evaluated right there. So this is specifically for healthcare training and skill development. And what we have done is we tested with our engineering students, and we found that it was quite easy even for them to learn how to do IV insertion, but we did not go and put them onto a real field and ask them to do IV insertion. But they were able to understand the entire workflow here pretty clearly. So I'm sure more of these use cases will help education, healthcare education specifically. So that's it from my side. This is another, it's not a health-related digital twin, but I'll just show you this. So what we have done is we have created a pretty accurate digital twin of a drone with all its physics and everything. So the idea is to train people, pilots, because these drones, which are typically agricultural drones, are at 20 kgs, 40 kgs weight, and a small twiggle in on the controller will topple the drone completely. So what we have done is we have created a pretty accurate digital twin of the drone itself, and we have created a mixed reality setup so that now you can control the virtual drone using a real controller. And we have gamified this experience. Yesterday in the virtual world and the modeling session, people were talking about gamification as well. So how can gamification be incorporated in a digital twin setup, specifically in learning and teaching method area? So this gamification is done in here. So they go through level 1, level 2, level 3, they get some points. If they land properly, if there is a rough landing, they get some points. And depending on that, they will be graduated to flying a real drone. So on similar lines, we have developed Industry 4.0 training twin. These are unrelated to healthcare, but just so that I'm showing you these use cases which we have developed in the lab. So this is we have used Microsoft Azure Digital Twin platform for communication. And this is a pick and place robot that we have, and we have created a digital twin, the structural twin and also the functional twin of this particular robot. Now, what we have done is we are able to maintain this particular robot, look at the temperature of the servo motors and everything in real time, and suggest that a certain part is getting heated up, we have to switch it off right now or something like that. So another twin, this is again for learning driving twin. This is a pretty decent replica of the Gnanabharati RTO. It's about 10 kilometers away from this place. The driving track of that particular RTO is being replicated here. And we have used Maruti Sia's car twin. And the physics of the car is also modeled pretty decently for Maruti Sia's. And you could sit in a gaming-like environment, drive this particular car, do parallel parking, reverse, everything, and you should be able to learn how to drive. And the RTO is also interested they have simulators, but they are very, very basic simulators. The physics is not that great. They have environments which are Autobahn kind of environments, but nothing related to Indian road conditions. So what we are trying to do is we want to create this digital twin. We are also working with IIIT Hyderabad, Dr. Shankar from IIIT Hyderabad, to create some of these scenarios, driving scenarios, so that we could train people and they could take the test on the digital twin and later move on to the real car. So that is something that we are trying to do. So these are some examples of what we have done in our lab, and for today's session in the healthcare track, we would be deliberating on some specific digital twins for the Kumbh Mela scenario. So thank you. If there are any questions, we are.
Since army units are also sometimes involved in this, we found it surprising that there's no immediate response for food poisoning, and food poisoning happens in one stall person, he gets a substandard food, and the whole lot and then you are looking for place to send the patients, and you can't drive them through the thing. So that's one. And second is, though the waters where you are taking the dip and all is not very deep, it's pretty shallow types, but there have been surprisingly drowning instances. I mean, it is so funny that the person is just in waist level, they saying, and kya ho gaya, pani pi liya, and he's suffocating type of thing. So, so if you could consider those inputs for your
evacuation of the patients,
responding to that, because everybody tries to get into respond, and you are doing more harm to the victim than to the, so how it can be modeled. And second thing is, what we found is, if ab initio the traffic flow is designed in such a way, and the placement of the medical stalls or responses are in such a way. We found 3 of the tents for the medical, they are together. Why? ये हम साथ आए हुए हैं. You are supposed to spread out. They are not willing to spread out for the simple reason हमारा खाना इकट्ठा है. So, you know, if those things can be factored in and given to the thing, and what we found is there are SOPs made. So if the digital twin says ki as far as the healthcare of such an event, these are the key factors which should be, and given to the district administration, when he gives the permission, he gets a digital twin of the SOP enacted and ensured, and only if they succeed, he gives the permission. So okay, I thought I'll just give, but one last point, that's all. You are saying how to find out ki where they are. These days, you know, kids use this friendship band. There's a small chip-based thing wherein you won't be able to communicate. If any person coming through the entry gate puts on this, we'll be in a better place to respond to emergency health things.
Great. I think these are valuable inputs. We'll have an offline discussion and probably put it into the.
Thank you.
Thank you.
Thank you so much. So we have been able to go with 3 presentations. We have had the presentation on transportation, healthcare, and disaster management. So 3 more presentations are left. That is, one is on environment and the 2 horizontal use cases. But because of paucity of time, I think we will take those presentations in during the closing, right? So there are 2-3 points which I would like to make. Firstly, that this is the last day of the 3rd networking event, and we are on the concluding stage of all the 4 networking events, and we will be having the final networking event in Hyderabad. And in the final networking event, we are expecting our minister to be there, right? So we expect all the moderators to, you know, kindly, you know, pace up and try to conclude the discussions and, you know, make some valuable insights from the discussions so that the objectives of these networking events is fulfilled. And also, after this networking event, at the point which was made by Mr. Rajat, that there should be discussions among the vertical sectors. So we will take those discussions through VC after the event. So that point is well taken. And after the event, I request all the moderators to please be active and, you know, contribute by giving the documents. So we have already created Microsoft Teams accounts for all the participants, and we will be adding you to that particular team of which you have been the moderator or the participant. So where the input document will be shared. So I request all to go through the input documents and, you know, give your comments so that we can close those input documents before Hyderabad event and have the final discussions in the Hyderabad event. So thank you all. So I request you to please grab your tea and please move towards your respective halls. Thank you.
Check.
Yeah, yeah.
Good evening, everyone. Welcome to the closing plenary of the Bangalore networking event. It has been in an insightful 2 days long discussion on all these 6 horizontal and vertical sectors. So we will be starting with the closing presentations by the moderators and co-moderators of all the sessions. So I request the healthcare moderators
Good evening, everyone.
and co-moderators
Welcome
to
to
the
present
closing
their,
plenary of the Bangalore networking
discussions.
event. It has been in an insightful 2 days long discussion on all these 6 horizontal and vertical sectors. So we will be starting with the closing presentations by the moderators and co-moderators of all the sessions. So I request the healthcare moderators
Good evening, everyone.
and co-moderators
Welcome
to
to
the
present
closing
their,
plenary of the Bangalore networking
discussions.
event. It has been in an insightful 2 days long discussion on all these 6 horizontal and vertical sectors. So we will be starting with the closing presentations by the moderators and co-moderators of all the sessions. So I request the healthcare.
So we started with the, can you switch? Yeah. We started with this particular use case in the morning, and we have looked at some of these slides. Maybe very quickly I will go through the slides. So for a mega event like Kumbh Mela, these are some of the things that might happen during the Kumbh Mela, like communicable diseases, heart stroke, heat strokes, respiratory problems, skin infections, accident due to injury, and people who may come there may have multiple comorbidities. So these are some of the risks that may happen during the Kumbh Mela. And you have seen this particular, kind of like a mind map of who are the stakeholders of Kumbh Mela in the morning. So the green ones represents the specific focus that we have in the healthcare track. But that's not the only thing that we have. There are event organizers, transport authorities, digital twins, individual digital twin, composite digital twins of transport, disaster response digital twins, which can also be plugged into this particular thing. And there are multiple data sources for crowd management data sources, health data sources that we may be utilizing. So wearables, people were constantly speaking about different wearables, and how could that open up a lot of possibilities for collection of data in real time. So one thing that when we are looking at a crowd of a few crores of people, then the cost and the economic model is something that we have to keep in mind. So some of the benefits of digital twins, specifically in this one, is we could simulate the entire scenario, how the crowd will be mobilizing, which part of the area is overcrowded, which part of the area is undercrowded, what are the various hazards in that particular area. We could simulate all of these things. At the same time, when we are simulating, it will help us in planning infrastructure, healthcare infrastructure, transport infrastructure, and also stations, put some reasonable stations in places where there might be high risks. And also create some predictive models looking at the historical data and analyze the crowd movement patterns, potential congestion points, and everything. So real-time monitoring of the crowd becomes very important when the event is happening. And how does this entire thing translate to? So we have seen some of these specific crowd management digital twins and healthcare digital twins in the morning. So the change in we have added a couple of slides to the morning's presentation. So what we have here is a typical scenario. We have considered a food poisoning scenario. So what will happen when somebody is infected with food poisoning in such a scenario? So somebody will report it, and incident reporting system will be in place. So the incident will be reported to the primary health centers, and the primary health centers will further notify this particular thing to the planning authority or organizing authority, who will assign an inspector. So the inspector can be an individual, certified certified professional who can go and visit the site, identify what is the problem, and take some action. So there will be another authority. He reports to that particular authority, a law enforcement agency or something, which can later go and take some actions, either close the eatery or something like that. So this is an entire thing. So what we could do is we could create such scenarios in a planning twin, and this entire scenario will function with the help of health training twins. So we could create such scenarios. We could train the personals who are involved in event planning, including the healthcare providers, the transport authorities, the law enforcement agencies, and so on. So health digital twin is very important in this case. So here, if you see it on the top, to your left, you can see that there is a health digital twin which is attached to the primary health center. So that is where we will be looking at health digital twin. And this is one more trauma response scenario. So if we could have green corridors. So this is an image of Kumbh Mela where there is a huge crowd. Imagine there is some event that is happening at that yellow color spot. How do we transport that particular patient to the nearest healthcare center? So one thing, if we are able to simulate those things like the way we do in the previous slide, we should be able to set up some green corridors, very small corridors, which which could enable quick transportation of patients to the nearest healthcare center. So once the patients are in the nearest healthcare center, we could have multiple such green corridors. There is also one more option here that is highlighted. You could also go through the river itself, so through boats. And you have a certain vehicle. It could be a hand cart. It could be a very small ambulance that can squeeze into small spaces and transport the patient immediately to the nearest healthcare center. And that is where you have a patient emergency vehicle, all of these emergency transport systems that will be the entire module will be coupled with this emergency transport systems. We could have a digital twin of itself. And later we have the hospital twin or a digital twin of a patient, digital twin. You will have healthcare providers, including nurses, doctors, ASHA workers, maybe, where you have more information about the patient. You could collect the information by putting some sensors on the patient. While transporting the patient itself, you could collect data using wearable devices. Some of these things you can do, and to do all of these things, you definitely need to train the personals who are kind of deployed on the site during the event. So that is where the health training digital twin will come into picture. So if you look at this architecture of a health training digital twin, this is specifically for skill development and capacity building. So we have the data, we have the 3D models. Maybe after this, I will reshare those videos that we saw in the morning, where there are 3D models that can give you a decent understanding of the internals of the human body and better understanding of what is happening within the human body. So if we have these 3D models and data, we have discrete health digital twins like a gut twin, the heart twin, a liver twin, and so on and so forth. This could be aggregated together into a composite twin, a human digital twin, which could be plugged into these scenarios with multiple different, for different health records of individual patient, different genomic data. There might be allergic to something. How do we identify those things? If we have the genomic data, if we know the history, the medical history, then we should be able to administer proper, the authorities or the healthcare providers should be able to administer proper healthcare. So that data can be used by students, interns during training. That is a training twin. So you create multiple scenarios, you allow them to play around, get their hands dirty, and then they will be able to understand what is the scenario, and they are better prepared. So their muscle memory, their place cells are all well trained, so that when it really happens, they know what exactly do, who exactly to contact, and so on and so forth. So we could use that for teaching. So a faculty in a university, a teaching university, a medical university could use these simulations for teaching nursing students, for teaching medical students, and so on. While the doctors, professional doctors and nurses could use this particular twin to perform procedural twin. So this can be an executable twin. While they are performing a procedure, they could actually look at this. They could collect the vitals from the patient, and they could understand this in a much more better way. So along with all this, definitely we need a pharmacy twin, which is another entity which will kind of complement to the healthcare infrastructure. Without pharmacy, it doesn't really function that way. So we can integrate it with another pharmacy twin, which can provide proper supplies of medicine and everything to the. This is a use case of a healthcare training twin. So this is what we had as far as the slides are concerned. So I will go back to our. Give me a minute. So I'll go back to some of the videos that we had showed in the morning. So this is an example of a discrete digital twin of a human gut, where we have multiple different millions of bacteria in our human gut. So good bacteria, bad bacteria, and such things. So when we are looking at these bacteria, a bad bacteria will create a lot of problems in your gut. You go to a doctor, you with a stomach issue, you go to a doctor will administer some medicine, maybe an antibiotic because it is a bacterial infection or something like that, and they'll ask you to come back after 3 days. So that is what we want to solve. So can we assist the doctor into understanding what is happening with the patient's gut even before when he is physically examining the patient? So there are about 5 different phyla that we have identified, which are very prominent in the human gut: Bacteroidetes, Firmicutes, Actinobacteria, Proteobacteria, Vericomicrobia. So these bacteria, the composition of this bacteria in some sense will define the health of a human gut. So what we have done is we have identified these, we have modeled this in the human gut model, and this is the virtual reality replication that you see on the screen. So the particle systems that we have used will represent the bacteria. This is the small intestine. We have color-coded the bacteria so that we know exactly what is the composition of the bacteria while visually looking at it. And we should be able to identify whether the health of the gut is good or health of the gut is bad. If it is bad, then the next step that we want to do is we want to see if we could administer a certain medicine kind of related to the drug, which is much more systematic, and see how the disease progresses, how the bacteria composition changes over a period of time. So if it changes in a positive way, then we could administer the medicine for that particular patient. If it doesn't change, then the dosage has to be changed in some way. So the doctor, even before he has administered the medicine, knows exactly what kind of dosage, what kind of medicine has to be administered to that particular patient. In another example, we have a heart twin. So all of us wear smart watches. We can collect ECG data out of these watches. So what we have done is we have collected the ECG data, we use this ECG, every 30 seconds of the ECG data is sampled, and we run a deep recurrent neural network. And this recurrent neural network will identify whether in that 30 seconds there was an arterial fibrillation or not. The arterial fibrillation is, if you look at this particular wave here, P wave, QRS complex, T wave, and U wave, so this is how your ECG signals will look like. A small deviation in this wave indicates that there is a problem. So just by looking at ECG data, ECG signals, doctors will be able to identify about 16 different cardio diseases. So what we have done is we have identified one thing, that is arterial fibrillation, in 30 seconds. So we take the data of an entire day, 24 hours, split into 30 seconds. And once we know how many such arterial fibrillations occurred for a specific patient, then we could compute what is the burden on the heart. And depending on that, we could say whether is it risky for you to continue like this, or do you have to meet a doctor. So we are assisting the doctor in early detection, in screening such of a few of these issues. So we are using, so as of now, data is one thing that we are also suffering from. All of us, during our verticals, during our horizontals, everybody were discussing about data and how we could have a clean data. We also don't have any idea regarding this. So, but what we have done is we have got some clean data set, a very small sample of data set. We have used generative adversarial networks to generate more data of the same kind, or a combination of these available data, and we have trained our models on this. It works perfectly as of now. We could see some 97% accuracy, but I'm sure when we deploy it out there, we should be able to see it reduce. Another use case that we have for a discrete digital twin is a biomechanical twin. This is specifically designed for remote rehabilitation. Somebody who underwent a surgery, they want to, post-operative recovery and all. So this is a twin where multiple sensors are deployed in the body, and you could track the human body movements remotely and suggest some of the physiotherapy things. In a training twin example that we saw here, we have designed a nice ward system where a nurse can wear the headset and try to understand what are the procedures for IV insertion. So starting from sanitizing their hand, going and rubbing alcohol on the patient's body, IV insertion, specific angle of IV insertion and everything. So this helps in safe skill practice. Otherwise, today we can see that nurses are trained on the bedside. A senior nurse will train a junior nurse on the bedside. And that can be risky. It may spread infection, it can have a lot of... So IV infection is a big problem in hospitals today. So can we solve it using creating a small training twin of a hospital is something that we have. So these are some examples that I have, and thank you very much. You want to add something?
To emphasize on what we have done today, we will also be going from a discrete level, coming to the patient, what would be the discrete twins first, and coming to the training, what would be the discrete twins, and what would be the different level of composite twins we could build upon. So not only the healthcare, and as also Aditya was outlining, we would also be looking at what our composite digital twins from the healthcare could expose towards district administration, the health department, or from the district, what could go towards the state governments, or what could go towards the center, in order to look at how the health of the country or the society could be leveraged. And also there were use cases described in the disaster or emergency handling, where there will be a collaboration between the healthcare digital twin along with the other digital twin about transport planning or the infrastructure enhancements that might be required. For example, the ambulance has quite a lot of time to come to the place where the incident has occurred, and what these insights could be translate towards the environmental plan or the city planning, and these are something that would be a collaboration between the healthcare digital twin and the other digital twin. So these are also something that we have envisioned, but probably that will be the next steps beyond the POC to be taken care. Yeah, thank you.
Thank you so much, Dr. Aditya and Ms. Punk from Nokia. So now we move forward with the second presentation for the day, that is on transportation planning vertical. So I request Mr. Rajat Mathur from BCG and Professor from PES University to please come up on the stage.
Good evening, everyone. Rajat Mathur, Professor. We were the moderator of the vertical on transport and mobility. And let me quickly start with a recap. So across 3 cities, so far the networking session, we have contributions of over 75 participants. They were cross-functional participants across multiple technologies, across multiple domains, etc. They were trying to make their contribution. So whatever we present right now is in a way culminating towards what Hyderabad event would be. And hopefully we should be having 100 plus there, as transport has the maximum traction so far. And all the, you see the participants who have come up who have been across all the tech, be it your privacy enhancing technology, be it your GIS 3D, telecom operators, hyperscalers, AI data scientists, map providers, 3D simulators, digital twin platform providers, domain experts. We got a huge bunch of experts who have been contributing thus far across all 3 events. So what we present is not just what we discussed today, but an amalgamation of what we have seen across the 3 events. So for us, coming direct to the point, for the proof of concept that we want to do as part of stage 2, we propose to have a use case which has been there, which we shortlisted in Delhi and have built up over a period of time, is to reduce traffic congestion of a city using digital twin. We propose that we take up the 2 sets of initiatives, 2 initiatives to do the decongestion use case. But before we jump to those 2 initiatives, let me just articulate a vision which Asit sir was talking about some time back, that Madrid is, let's say, 15-minute city. Can we really put an aspirational vision that, okay, can it design a city of, let's say, Delhi, Bombay, Gurgaon, or whatever city that we end up choosing it to be, let's say, let's say X kilometers in Y minutes by reduction of traffic staff by Z% or so. That is what an aspiration vision we want to put up there. And to do that, we say that there are two initiatives that we talk about. The first initiative would be the intelligent traffic management, something which we discussed, deliberated, and shaped up firmly in Delhi and Mumbai. But a quick recap, this includes a better traffic management through real-time controlling of your one-ways or two-way traffic, your parking, your traffic policeman deployment, and so on and so forth. We believe the customers for this would be the traffic police commissioner, obviously. And the value prop for why should a traffic police commissioner should listen to us is we will say that we can optimize the workload of your traffic constables who are working on the ground. Instead of making them work for 18 hours, 16 hours, or a long working hours, we can reduce them and make them more efficient and effective. The second one that we talked about is what we discussed in Bangalore session, which we framed in Bangalore session, was a multimodal public transport optimization. And here our approach is that can we improve the modal share of public transport, which means that, as the name suggests, if 10 people are traveling, how many people are using public transport? Can we increase that share? Which includes the optimization of bus route, frequency, capacity, and in the metro, the capacity and the schedule, because obviously you cannot change the routes of metro overnight. The value prop for this, the customer for this would be the MDs of metro and bus services of the city, the corporation of that. And we need to reach out to them so that they get excited about this kind of a value prop rather than just being presented only on the paper here. The value prop for them would be to improving their ridership. That's what the skin that they have in the game, that if we can help them improve their ridership, they may be more interested in listening and actionizing this use case on the ground. So we propose to consider Delhi or Bangalore as a pilot for stage 2. What we want to optimize in that, what we want to achieve in that is first initiative is, of course, the flow. We want to baseline or measure the flow, the flow which is the cars per kilometers per lane, average speed or travel time on select routes, utilization of traffic workforce, and of course the AQI. In the second initiative, the multimodal optimization that we say the modal share of public transport, that obviously has to go up because if there's a ridership increase, that has to go up. Asset utilization of, let's say, coaches and buses. If there are extra buses, can we rationalize them? Or can we put up, let's say, some extra coaches there and put up in the high high velocity routes, and so on and so forth. Now, in order to do that, if you have to do this POC and make it real, really hit the ground running and make an impact rather than just being on this paper, we need to have a baseline approach. How do we design on that? Our first would be initiative to get the baselining from video analytics, get the data on flow and average speed, perhaps telematics data to get connected from the connected cars, sensor data from which can give us AQI or carbon emission. This will set us as a state. Currently, this is where Delhi, Mumbai, or Bangalore, or whatever the city that we choose is. These are the needles which we need to move with our use case and initiatives. Similarly, for initiative 2, public transport utilization through tickets sold, we understand that people would be open to share at least their ticketing data. And utilization of assets, again, something if we go and work closely with the MD, if we just engage in a formal project with them, then they'll be more than open to share this data. A comprehensive components. So do I need a quick recap? Should I go do a quick recap of 30 seconds? I'll do that. So we are talking about one of the vertical use cases on horizontal and mobility. That is the vertical that we had. In that, what we had done in last 3 sessions across Delhi, Mumbai, and of course now in Bangalore, thanks to the hospitality, we have more than 75 participants in a cross-functional manner. They have come across the multiple domains, multiple technologies, multiple sectors who have contributed to this exercise. The use case that we have narrowed down or zeroed down is reduce traffic congestion for a city using digital twin. The objective is that after 6 months, can we really make digital twin POC and a pilot happen? 6 months to develop the POC, and maybe subsequent 6 to 12 months to do a pilot and get an impact on the ground. Now for that, we thought of a vision, and thanks to Asit sir, the idea that when he suggested that Madrid and in Madrid or Amsterdam, these are like 10-minute cities or 20-minute cities. So can we also push ourselves and think of a vision that where our cities can be, let's say not Delhi, Bangalore, maybe some other small tier cities can be a 20-minute cities where you cover any number of kilometer or X kilometer within Y minutes with a reduction of your Z% of your traffic workforce. So we got 2 initiatives or sub-use cases which are identified on that. So better traffic management through one-way, two-way management of streets, parking, workforce, and of course, workforce deployment, better workforce deployment. I mean, these are the 3 levers that a police commissioner would have. Our customer is nothing but the police commissioner. The police commissioner of the city would be our client, our customer, who will be willing to do this project with us. And his value proposition would be that we're going to optimize the police workforce load and make them better prepare them to respond in a better manner. The second initiative or sub-use case is the multimodal transport optimization, where we improve the overall ridership or the share of the transportation of the share of riders into the public transport, which in turn optimize the bus route, frequency, metro capacity, and scheduling, and so on and so forth. Here the customers would be the MDs of the corporation of bus and metro, and with the value proposition that which improves the overall ridership for these corporations. If the bus ridership increases, there would be some skin in the game from the CEO or the MD of the bus corporation, and same with the metro. Now, pushing ourselves to make it real, if we really want to go down and prepare a 6 months POC and then subsequent pilot, these are the 2 sets of KPI, the sets of KPI we need to be concerned about. First one, for the initiative 1, the flow, which is the cars per kilometer per lane, average speed, or for that matter, utilization of police workforce on this. On the initiative 2, it's the modal share. If we really need to move the needle, then this number really have to go up. If we really are serious about multimodal transportation, this is the number that has to go up. Asset utilization, and so on and so forth. How do we baseline it? In order to deliver a successful, on-ground, impactful project, we have to have the baseline or as-is numbers first. So to do that, for these KPIs, we will do, let's say, video analytics or telematics to get the KPIs across the initiative 1. Similarly, for initiative 2, with the ticketing data, we can get the as-is state, that what are the current KPIs, how good, bad, ugly they are. And then we should be focusing on moving, as I said, moving the needle to improve these KPIs. Now, how do we do that? How do we develop this twin so that it improves those KPIs? Our comprehensive list, these are the exhaustive data sources that we had put up there. Predominantly what we have discussed across all 3 cities, fairly doable exercise to get this data. Some data can be costly, that's a separate issue. But there is no constraint coming out as long as there is a right architecture, right governance in place. This data can be taken and can be used for the POC or the projects there. Very similar on the sandbox or the architecture part. So you need a sandbox, you need privacy enhancing technology, behavioral models. Long story short, the big message here is that all these technology components are nearly available. Capability exists in some shape and form. And hence, if I can use this word, there is a decent to good product market fit for such kind of an offering here. This is a federated architecture. I won't take a lot of time. Maybe Sanchit and the team from the data side, they will cover this more around that. But this is something, thanks to courtesy to them, we're able to have a quick functional architecture there with all the data layers, data sources being on the top, a data fusion layer, the twin and the AI platform, visualization, and then more importantly, the client and the customer there. If you see the OD matrix, we deliberately put it as an orange, saying that if there is a concern by telcos that I cannot share this, even the aggregated non-PII, even business, to some extent less business sensitive or business sensitive information, then we have an ability to do a federated learning through this. And through this federated architecture, we can address their concern and yet able to utilize the information and knowledge that they end up sharing. Few imperatives, if you want to hit the ground running after successful development of 6 months, these are the few imperatives that we should be aware of. First, the levers of value delivery. The police commissioner, or let's say the MD or of bus corporation or the metro corporation, what are some of his levers? His levers would be the first one. The commissioner would say there's time-specific workforce management. One constable can be deployed from 10 to 2 at one place, 3 to 5 at other place. So with one constable, he can manage his entire city in a better way. One way, two way, better lane management, something giving back to this, giving back to the citizens as well, and it's well within his control. Parking, another thing which is well within the control there. We have deliberately kept traffic lights because these traffic lights takes a huge amount of time to get it implemented on ground. Hence, these levers were chosen because these can be implemented in 8 months, 9 months and so that you can see the impact of this POC when it was implemented on the ground. Other key success factors would be, we definitely think, I think there was a good, again, a conversation that we need a Sangam organization for governance and managing these use cases. Experts from transport and mobility, regulators, and so on and so forth. Sources of funds. There was a long list, I just summarized it, but more importantly, the customer is the king. So if we can really create a value, if we can really create on-ground value for traffic police or the bus and metro corporation, they should be the first one. TDDF or research funds or even CSR and escrow fund or PPP, these are few ideas which have come out. That's what our plan is for launching this 6 months POC. That's what we will be working on. We first need to have a good ground zero or a pre-work there, which is, I mean, we are assuming right now that Delhi and Bangalore would be very open to talk to us or engage with us. May not be. So we really need to have a very sharp proposition, what we bring to the table. What is our value proposition for that? We need to validate these problem statement with the clients. And of course, then the setup of infrastructure, baselining, digital twin engine and AI engine, and final report and conclusion there. A simple governance, a weekly review with Sangam on-ground team and the client on-ground team, and a monthly review steering committee with Sangam leadership and the client leadership. So these are the final concluding next steps. I think we have cooked up our 2 use cases fairly well. We can definitely work to sharpen up our value proposition and make it over stronger as why the MDs of bus and metro or the police commissioner be interested in us. Quantify these benefits. Let's say the workforce reduction. Can I really say 5% reduction of workforce for traffic police? Maybe, may not be. Increase revenue through public transport. Very good opportunity of a ridership improvement. Other revenue models such as sharing information with aggregators and enforcement agency, something which are additional revenue. Last but not the least, collaborate with other twins, other verticals of, let's say, environment twin and disaster twin. It's incomplete without that. That's pretty much. Thank you so much. Any questions, thoughts? Happy to take them.
Thank you so much, Rajat and Professor from PES University. So now we move forward. We have our guests for today, so we will be pausing for a while with the presentations. We have been able to have the 2 concluding presentations, one by Dr. Aditya on healthcare and the second on transportation. So now I would like to move with the closing plenary ahead. So today we have with us the Vice Chancellor of PES University, that is Dr. Surya Prasad J, and Shri Saurabh Gupta, Special DG Telecom, Karnataka LSA from Department of Telecom. So I request you all to please give a big round of applause to welcome them. So now I request Shri Asit Kadian, DDG from DOT, to present a plant to Shri Surya Prasad J, Vice Chancellor of PES, to welcome him. Thank you. And then I request Asit sir to please present a plant to Shri Saurabh Gupta, Special DG Telecom from DOT, and welcome, sir. I request Shri Pranay Devakar, ADG, to present a plant to Shri Galgali sir, DDG Security from Karnataka LSA, and welcome, sir. Thank you so much. So these 2 days have been very insightful and interesting, and the discussions have been, output oriented, I would say. So I would just brief in short that what exactly we have done in these 2 days. So I please request you to switch the screen. Please switch the screen at the back. So these 2 days have been, we have had discussions on 6 breakout sessions, sir. So there were 4 vertical sectors on which Sangam is participating, that is working on. That is, one is transportation, which we just heard about. And the other is enabling healthcare access and service. And then we have got a use case on environment. And then the 4th one is on disaster. So in all these 4 verticals, we had got moderators, co-moderators, and DOT representatives who were steering the discussions. So we have had around 100 participants for these 2 days from the industry and academia to participate in these discussions, and their inputs have been really valuable. And in the horizontal sectors, we have had 2 sectors on which we have discussed. One is the solution architecture, including data, AI, privacy, and governance. And the second one is virtual world modeling and simulations. We have seen the output of 2 presentations for the day. So this is the brief about the Sangam event which we have which we are concluding today. So with this, I would like to welcome Dr. Surya Prasad J for his special address to the audience. So please come.
Good evening. Special welcome to dignitaries from DOT, participants of the Sangam-Digital Twin. At the outset, I think it's a wonderful event that PES is hosting, and we take a lot of pride in ensuring that there are some amazing minds that have, come to PES to discuss on some very interesting thoughts that are there. Whenever we talk about digital twin, the first thing that comes to mind is we are all aware that everything in this universe is created twice. Once in the form of abstract, and the second one in reality. But if you take a look at in digital twin, I think it's not just created twice, but in reality it gets created, more than once, so that it is going to be more appropriate, so that there are a lot of things that can be done there. When I say a lot of things that can be done, I think one of the things that were indicated is disaster management. Today, with a lot of sensor technologies coming into picture, the ability to ensure real-time data is going to be available, right? There is so much that can be done to foresee even some of the things that might go bad with one small start of something that could be catastrophic in nature. Whether it's an aircraft or it's a human being, right? With all these sensors being embedded into various things and AI helping us big time, giving us this prediction as to, okay, this is what it is. Vibration in this particular part is too high. or there is too much of heat generated in this particular one. This heat is going to ensure that going to have a problem on these kind of wires that are there, etc. I think there is so much. So with a lot of interesting sensor technologies coming into picture and the ability to munch or crunch the data that's being generated in real time so that the disaster that could happen can be averted, in various ways. I think some of the things that are there, we had an event just last year wherein we talked about AI in education, and then we had one of the professors come in from IIIT. He had a very interesting model. He was trying to predict, a small infant, a neonatal incubation, thing he had, ICU unit that he had developed. He said with what he has developed, he can predict whether that small tiny baby is going to go to a septic shock or not half an hour before. You can understand how critical that half an hour is going to be for a doctor to ensure that the right kind of medication and the right kind of decisions are going to be taken so that they could save that life. So he had some very simple, interesting things with collaborating, including a thermal camera in the ICU, small unit that's going to be there, monitoring the temperature. And then he said very fundamental, whenever there is any infection, that means to say invariably the temperature goes up. So he was just monitoring that, looking at what is happening to the temperature part of it, and then half an hour before the small baby could go to septic shock, he was able to kind of identify. It looked very simple, but if you take a look at it, the person who has done that is actually an engineer, but has also done, his medical background. He was able to understand and merge these two things together. So today, irrespective of what we talk about in digital twin and so on and so forth, I think collaborative work is going to become very, very critical. I was here just for this last few minutes when they were talking about the transportation problem and so on. I just had one small input for them. I think what we need to understand and identify is why are we traveling? The purpose of our commute. If you know that clearly, maybe then we will understand, is it only for work? Is it for pleasure? Where are we going? Is it school children who have been? Where are our schools? Where are our workplaces? Is there something that needs to be reorganized? What time? And so on. I think we need to get to the very simple fundamentals of things what we are. The reason why I tell you this is, when I was working at Motorola, this is a very simple, interesting problem. Motorola wanted to come up with a mobile phone for the elderly, right? Because they found out a market in the US, in 500 million people, close to about 20% were senior citizens, so they wanted to come up with a mobile phone for the elderly. I was also participating in one of those discussions at Motorola, asking what should be the features, right, that should be there in a phone that's going to be created for the elderly. Pretty much everybody talking about, bigger font size, screen should be larger, audio should be better, and there should be a, hazard or whatever, SOS button that's going to be there. And all these kind of inputs were coming up. The keyboard should be bigger, and so on. All those inputs are valid, but if you take a look at it, it's just a perception of what the elderly is. Pretty much looking like the deaf and dumb and blind and, unable to handle themselves or a technology that's going to be there. One among the group just made a very simple observation. That observation is, have we got this input from actually the ones who are going to use it? In the meeting, all the people who were there were a bunch of people who were less than 30 to 35 years old and giving specifications of what a mobile phone should be for the next generation, right? So when we're talking about any of these, whether it is digital twin or not, requirements becomes very, very critical to understand what it is and then build a system that's going to make sense, and the impact of that is going to be there for everybody to see. Digital twin is something very, very critical or important for everybody going forward, irrespective of their domain and so on. I can understand we have Aditya here doing quite a bit of work on the AR, VR part of it. There's a lot of people think that it's more of simulation, but it is not. It's where the confluence of lot of sensors coming into picture, data being sent out, munched or crunched at a very high speed so that it is going to become more meaningful for the decisions that needs to be taken up. And of course, a lot of this sensor technology, communication, AI, ML, all these coming together, your applications could be different, but still making a tremendous amount of impact for all of us. So we are highly thrilled to be hosting this particular event at PES. I'm sure there's going to be a lot of outcomes, that's going to be there rather than just the sessions that are there. There's a good think tank that has kind of come together at PES. We look forward to engaging in more stronger collaborative work going forward, because what we are blessed with PES is not just the infrastructure. We have tremendous intellectual power. That is our students. We get some of the best of the students in the entire country. And that, if you're able to put or utilize the horsepower that is going to be there, trust me, it's going to be a very interesting situation. So our interest is also selfish in trying to host these kind of things, because the problems that are going to be discussed here are the problems that are going to become our capstone projects for our students. So, it does help. Maybe the solution, what it does, might not be actually what's the outcome that you're going to be looking, but maybe that's another approach that's going to be explored. Good or bad, somebody else is trying on it. Good or bad, there is an outcome. But I think the best thing is the entire ecosystem will benefit from this entire thing. So at PES, thank you very much for DOT for coming to PES. We look forward to a stronger collaboration with all the participants present here, and all the very best for all the future endeavors that are going to be there. Thank you very much.
Thank you so much, sir. It has been a great experience for hosting this event at PES University. We are really thankful to you. Next, I would like to invite Shri Saurabh Gupta, Special DG Telecom, Karnataka LSA DOT, for the keynote address.
Hello. Good evening, everybody. Mr. Suraj from VC, from PC University, and all the delegates coming from all the country for discussing this, and this Sangam. Sangam is something, naturally everybody knows that it's a confluence of many things and all. I'm really privileged to be here today, be a part of this, and listening and hearing something about the digital twin and all, though it is a DOT initiative, but yes, I was really thankful that the venue, 3-4 venues, and Bangalore is one of them. So I heard this is a confluence of the innovations. So as we all know, Sangam is whenever they meet, and the evolution of Saraswati. So I think is a confluence of innovations, and so I think many Saraswatis would have come out, and especially on this place of Saraswati, it's the best place to discuss on these very conceptual things, and the thing which is about to be as a point of future, the concept of future. So this PES University, I think it's a right venue for this, and really at this occasion, it's not being selfish, it rather is a cause of the whole mankind, which this PES has accepted this and participated in. They not only participated, I think they supported by giving the infrastructure facilities for conducting this and be part of DOT initiative for this. So I look at this not an event, this is an initiative towards betterment of the whole infrastructure, making the infrastructure smart so that we all will be able to serve the citizen or the user in a better way, and much convenience to them for living. it's as rightly said and pointed out, we should really keep the citizen or the user in the center when we are discussing all these use cases and all these things. As far as transport case, I was listening, I was in Bombay, and then I recollect the just incidents. I mean, most of them I visited, heavy traffic and all those times, about 2 decades back. That time, even if you go to the Bombay, South Bombay, they were using manually. Once you go to south side, they will use for one way 3 lanes. The other way, return evening, they were using the other side of 3-way by temporary shifting. So that is a very crude method that was doing. But I think with the so many tools and so many intelligence with us, so many data and collection and merging and all these things, yes, this is the right time. We must have come up this idea, and the core sectors which have been selected for this transport, health, disaster, and I think environment. These are really strategic sectors which not only their sector, they support the overall system, and overall all the sectors support all the sectors. And telecom naturally have been the base of it, and it is really DOT initiative. Really, I appreciate this, and really congratulate everybody. And I feel today, after the deliberation of 2 days full, and all sectors, horizontal and vertical, whatever you have discussed, it must be much insights would have generated, and great directions would have come. And ultimately, it's not the final recipe. It's at the start of collecting the ingredients. I think this is that stage we are, stage 1. Stage 1 was very initial thing. Just we are trying to collect the ingredients, the quality gradients. And I feel this is the best place and best occasion. And I hope, I wish this digital twin initiative will definitely reach its height in this very short period. And hope DOT will be able to present some way forward to the government, and to go ahead with all the sectors together, and we'll be able to give really a good lifestyle and this thing to all the citizens. With this, I thank everybody again, especially PES University, supporting us in giving the venue as well, participating in this actively. Thank you. Thank you.
Thank you so much, sir. Now I would like to invite Shri Pranay Devakar, ADG from Department of Telecom, for the vote of thanks.
Good evening, everyone. As we conclude the Sangam networking event at Bangalore, I'm honored to extend our heartfelt gratitude to everyone who made this event a successful event on behalf of Department of Telecommunications. First and the foremost is I'm very grateful to Vice Chancellor, PES University, and Head of Karnataka Field Unit of DOT for their gracious presence in this event and their visionary guidance for the event. I would also like to express our gratitude to PES University, their professors, especially to Shelja ma'am, Aditya sir, and Vadiraja sir, for moderating the sessions and for looking all the organization part. A special thank to our esteemed participants, moderators, co-moderators, domain experts, especially from the industry. Your active engagements and collaborative spirits have been at the core of Sangam's success. Innovative ideas, granular details, and the comprehensive blueprints that have evolved during the sessions are basically the evidence of the willingness and the dedicated efforts that we all have put into this. We also extend our appreciation to the organizing team at the PES University, our DOT unit at the Bangalore, and the TCOE team who's helping us for organizing the event. Finally, thank you all the attendees for your participation and the contribution. Your presence and inputs have made this event truly impactful, paving the way towards the transformative advancement in the Sangam. Last but not the least, a very special thanks to the student volunteers of PES University. Their dedicated and tireless efforts for the organization, especially taking us to the different rooms, different halls, to the cafeterias. And I wish great success to all of you for their future. So now we are signing off from Bangalore and now heading towards Hyderabad next week for the next and the last networking event of Sangam. And I'm happy to announce this, that we are having a tentative schedule of Honorable Union Minister of Communications to join there in the Hyderabad event. With this, I'll be closing the day, and thank you everyone for be there. Okay, so we'll be having a tea outside this room. Thank you so much. Please join us for the tea.